Morning, everyone. As Rod said, I'm in EPA's Office of Research and Development, and one of the things that I do is do research on the measurement methods that are needed to support regulations. And somewhere along the way, I got involved with gas metrology. For over 20 years, I've been one of EPA's primary collaborators with NIST, and so I work with them closely. So I'm going to talk a little bit about reference gases. So just to give you an idea, and am I going to get the notes for this, or just out of curiosity? Maybe I'm not seeing them. But anyway, from a background standpoint, EPA requires what are called protocol gases for regulatory monitoring, and so that to ensure a uniform measurement basis. NIST is at the center of that. These gases are prepared according to the Green Book, and I'll touch on that a little bit in a minute. But protocol gases rely on NIST traceable reference materials or other NMI through a declaration of equivalency. Right now, the availability or unavailability of these reference materials is limiting EPA's programs. It's not very easy to develop new gases. It's not easy to maintain the gases that are in existence now. So an alternative option is what we need, and that's what we're working on. So in the back, guys, can you set it up so I get to see my notes? Or is that possible? Help me anyway. So here, this is the traceability protocol. This is where all the procedures for establishing the uncertainty of what we call protocol gases are documented. There are spreadsheets. This has been around for quite a while, and it is basically the cookbook for gases. As far as EPA regulations, there are a number of regulations that require these gases. Probably most people are familiar with EPA's acid rain program, the trading of NOx and SOx, so protocol gases are required there. But then you have the Clean Air Act regulations, the Part 60, Part 63, where there are multiple methods. There are literally over 100 methods, many of which require protocol gases. And then you have beyond that the states and localities that require these gases. Ambient gases fall in this category. Not going to talk about that. Not going to talk about mobile sources. But so where do we get these reference materials? We have NIST standard reference materials. That's what NIST sells. We have NIST traceable reference materials. Those are gases that the gas vendors send to NIST to be named with a characteristic uncertainty. And, well, that was interesting. There we go. Thank you. And then we have NIST research gas materials, which are one-offs. So the NTRMs are named as a batch. And then we have other National Metrological Institute gases that are acceptable, VSL gases, NPL gases. And again, it's the limited availability that is really hurting EPA's program, and COVID really took its toll on the U.S. So NIST lost a lot of really quality people, and their ability to keep up with the standard reference materials has been hindered, and that just puts us further behind in the ability to develop new gases. So let me give you a couple examples here. I'm going to talk about HCl and ethylene oxide. So early in 2015, I believe, EPA promulgated Performance Specification 18. Performance specifications are the monitoring methods. One is for the installation, and then the Procedure 6 are the quality assurance procedures. They require gases. And unfortunately, EPA had two regulations go forward for the utility industries, the MATS rule and the Portland cement, where it required HCl monitoring but there weren't gases available. So we had to come up with an interim solution, and I'm going to talk about that interim solution. Alt 114 was the start. So what is Alt 14? It is broadly applicable to a source category. It's how you can fix an obstacle in a regulation without going through the formal promulgation procedure. So EPA can accept a request or a petition and then respond to that. It can be handled on an individual basis. It could be handled in broadly applicable. And that's what Alt 114 was. Alt 114 was a specific request from a gas vendor. And so the good news is that HCl gases have been around for a while. We've used them. We just didn't know what the exact quality of them was. So my group, I worked with a specific gas vendor, Dr. Stephen Miller, formerly at Air Liquide, now Airgas, to come up with an approach that's based on essentially a dual verification process. It assumes that a gas is not reactive, in that you can actually establish the initial concentration gravimetrically. There are some very, very good procedures out there, low uncertainty, less than 0.5% uncertainty for preparing gases. And it's important to point out that gravimetric preparation by gas vendors has multiple levels. So this is at the highest level. So what we can do here is create a reference material that is essentially equivalent to an NMI reference material, at least functionally, and it requires verification of the gravimetrically prepared value. That's called the gas manufacturer primary standard, and that approach was something that we developed with the gas vendor. They use wet chemistry. They sampled the gas, and then by ion chromatography, the analytical was SI traceable based. So you establish the secondary verification via SI traceable approaches as well. So then we have what are called the GMACs. These would be the protocol gas equivalents. The GMACs are the gas manufacturer's alternative certified standards. And again, you prepare this gas gravimetrically, but now you use the GMPS instrumentally to verify the concentration, the gravimetric concentration. As long as it meets the performance criteria, that gas is able to be certified. You actually use the Green Book procedure to name that gas, and you have a choice. You can use the gravimetric value, or you can use the GMPS named value. A specific certificate of analysis is required to go with that. So it identifies the gas as a GMAX. It's very similar to how you would provide a certificate for a protocol gas. It has the stated uncertainty. It has the expiration date and all the information that you would normally see. And I better speed up. So let me give you a more current example. We have just proposed in the U.S. a regulation for ETO emissions from commercial sterilizers. That's the national emission standards for hazardous air pollutants. And I'm assuming that these slides will be available later. This has a link to the Federal Register. But what's most important is that the emissions monitoring approach, which is assumed to be the regulatory compliance approach, was proposed along with this regulation, and it includes a specific procedure for these gases. So unlike HCl, ethylene oxide gases really haven't been in much demand, so we didn't know too much about them. Are they stable? Are they accurate? So we did a study with as many of the U.S. commercial gas vendors that were willing to participate, and tried to study what we could about these gases. So just to give you a feel for it, we had 4 or 5 different gas companies. I'm not going to spend much time on these. These Basically, all the values were kind of all over the place, at least initially. So what is their basis for naming their cylinders? Are they using a gas that they prepared themselves? Are they using computer or computational reference spectra like HITRAN? So everybody was doing something different. So we were trying to harmonize that. We also evaluated stability. We evaluated the transfer. We looked at 6 different sample lines and different regulators. You know, how do we get this down a 300-foot sample line? So we looked at, you know, high levels. We looked at very low levels. And what we found is that the quality was very variable, vendor specific. We could get standards down to 100 ppb. We feel confident in that. We actually need to go down to about 10. But so how are we going to make the gases, the protocol gases that we need? How do we make the GMPSs and the GMAX? So as I mentioned, Performance Spec 19 has that. Appendix B is what's contained in Performance Spec 19, and it is a much more detailed version than what is already in existence in Alt 114. So it's got the procedures for establishing the GMPS as well as the GMAX. It is a temporary solution until the NMIs can produce these gases, which is probably several years down the road at the earliest. But what is most important is that this is a path forward for other gases of interest, particularly the compounds that are on the Clean Air Act hazardous air pollutants list. If you're familiar with that, it's like 189 compounds, the majority of which are organics. EPA is moving towards regulating these on an individual basis. So this is a solution. Again, the GMPS approach is very almost identical to what's in Alt 114, the gravimetry. There's more detail in there about how to derive the uncertainties, the importance of the purity of the starting material, quite a few things. And then you have the certification process, and I'll talk a little bit more about a vendor approach to that. But again, there's more information in there about stability, and that's a very important component to any reference material. So just touched on that. I notice I've only got like 2 minutes left. So what's important is that the stability testing that is done by the gas vendor determines the length of time that the standard can be functional. So that's much more detailed, much more rigid. All that information is in PS 19, which is available currently. So just to give you a feel for other things in there, you've got a certificate of analysis. You've got just the standard things that are to be reported. Right now, it does not require a specific uncertainty. So the Green Book basically tells you how to get the uncertainty. It doesn't specify what the uncertainty is required. So that's more of a fit-for-purpose approach right now. So for currently, that is based on GMAX having an uncertainty of about 5%. So this is actually some data from one of the gas vendors, Dr. Miller at Airgas, where he has prepared GMPS candidates. These are not GMPSs yet because the rule is not formal yet, but it shows you what's possible. And what I really wanted to talk quickly about was the approach that's used to verify the gravimetric value. There's a technology out there called PolyArc, and what it is it's a flame ionization detector, but what it does is it creates a uniform response to all organics. So it uses a catalyst to oxidize the organic to CO2, and then another catalyst to reduce it to methane, so that all hydrocarbons give the same response. Like formaldehyde does not give a response on a normal FID the way it would on the PolyArc. And so what's unique is then we can calibrate this instrument with an SRM. So there are SRMs for things like propane. So right now, it looks like this technology exists. It can be applicable to other organics. So we're getting close. Wrapping things up here, summary messages is that we need to provide these reference gases in the absence of NMI reference materials. So we are looking towards the gas vendors now to establish these capabilities. What I can say is that my colleagues at NIST are on board with this. I'm actually collaborating with the gas metrology group and getting their input on what our approach should be that's consistent with them and help set the table for them. So the good news is that we have a way to move forward and expand the universe of reference gases of known quality. And I think I'll stop. Just let me add quickly, these are some of the other gases of interest right now that we don't have protocol gases, but we want to regulate for. Quickly, Ned Shapley at OAQPS, and I'll talk more about OAQPS in a little bit, is the focal point for PS19. And Peter Carey is one of my colleagues. Bob Wright is the guy behind the Green Book. And we really rely on the gas vendors, and Stephen Miller and Doug King at Airgas are incredible partners. And I'll stop.